Imagine a driverless taxi, right? It pulls up to a charging station in the dead of night.
Yeah, there's no human driver to step out and, obviously no attendant to plug it in.
Exactly. So how does the car actually know that the station it's connecting to isn't, a hacker sitting in a van 50 meters away?
Right, trying to launch some sort of catastrophic denial of service attack on the whole city's power grid.
Yeah, exactly. It sounds crazy. But it turns out the defense against that kind of, sci-fi heist scenario comes down to literally 1.5 billionths of a second.
Which is just wild to think about.
It is. And we're going to get into exactly how that works today because, well, we are currently caught in this really messy, chaotic middle ground.
Yeah, there's a huge gap between the marketing and the reality.
For sure. If you look at the marketing for the energy transition, it's this friction-free utopia, right?
Sure.
Silent, autonomous cars gliding under these gleaming solar canopies.
But behind that Hollywood facade, it's a lot of 2x4s, duct tape, and just engineers scrambling to figure out the actual physical reality of building an electrified world.
Exactly. So whether you are prepping for a high-stakes logistics meeting, or maybe you're trying to make sense of the clean energy transition, or you're just insanely curious about how the future actually gets built, this deep dive is custom tailored for you.
It's going to be a fun one.
Yeah, the overarching mission today is really just to cut through the noise.
Yeah.
We are synthesizing a massive stack of sources for you.
We've got everything from investigative reports on fossil fuel marketing tactics to commercial hardware rollouts.
Right, all the way down to a super dense academic paper on the specific software protocols required for driverless charging. But we actually need to look at the narrative battle first.
Yeah, because before we can appreciate the technological solutions being engineered, we really have to understand how legacy and energy sectors are fighting to control perception today.
Right, the optics of it all. So, The Guardian published this fascinating look at the Propane Education and Research Council, or PAR. They serve as a U.S. lobbying group for the propane industry.
And the data in that report highlights a massive shift in their strategy. PRR actually increased their advertising spending by 17-fold.
Wait, 17-fold? That is insane.
Yeah, they jumped from a $1.7 million budget in 2021 to nearly $30 million allocated across 2022 and 2023.
Wow. That kind of budget increase signals a total strategic pivot.
Yeah.
And the target audience is what really caught my eye in the source.
Where were they spending it?
They are running these campaigns on platforms ranging from YouTube Kids to Fox News.
Oh, wow.
Yeah, and the core message is this massive rebrand, basically positioning propane not as a fossil fuel, but as clean and renewable energy.
Which is quite the leap. But right in the source material, there are internal meeting leaks that lay the psychology completely bare.
Oh, right, the board member quote.
Exactly. A board member was recorded noting this trend where 25% of millennials and Gen Z mistakenly believe natural gas is a renewable resource.
Which it is not.
Right. And the board member's takeaway was, quote, "There's a perception out there, not reality, but that's perception. We can attach to that for propane."
Attaching a product to a known public misconception. That is a powerful, if somewhat cynical, marketing lever.
It's entirely about shedding the dirty fossil fuel label. But the physical reality, according to the data in the report, is that only 0.04% of propane is actually derived from non-fossil sources.
Right, because the industry talks heavily about, renewable propane synthesized from the Camelina plant.
Yeah, but currently 99.96% of the propane in use is a direct byproduct of crude oil and natural gas refining.
It's kind of like, slapping a plant-based sticker on a greasy potato chip and marketing it as health food. Technically, a potato comes from the ground.
That's a great way to put it.
But let me play devil's advocate for just a second here. The sources do explicitly acknowledge that when you burn propane, it emits less carbon than burning coal or diesel.
That is true, yes.
So if a city replaces a fleet of old diesel buses with propane buses, local emissions do go down. Doesn't their claim of being cleaner hold some actual merit?
Well, the definition of clean is highly contextual, right? Propane is cleaner than coal, sure, but it still emits more carbon than natural gas when burned.
Yeah, could that make sense?
And the vital context highlighted in the source is really the broader macro timeline. Reaching global net zero emissions by 2050 requires a substantial absolute reduction in all fossil fuel combustion.
Right, so we have to stop burning stuff eventually.
Exactly. Transitioning a diesel fleet to propane does provide a short-term emissions dip, but it requires this massive capital investment in new propane infrastructure.
Like new tanks, fuel stations, modified engines, all that stuff.
Right. And that capital expenditure essentially locks consumers into fossil fuel dependency for the next 2 decades.
Oh, I see. Because you just bought all this expensive gear, you have to use it.
Exactly. From a climate science perspective, it's a stopgap that delays the actual transition to zero-emission infrastructure.
Got it. So while legacy fuels are surviving by, managing public perception, the actual zero emission sector is just slamming face first into physical reality.
Yeah, the infrastructure bottleneck is brutal right now.
We all know EVs are scaling rapidly, but actually delivering the electrons to those commercial fleets has become a massive headache.
The main bottleneck is the local utility grid. Upgrading transformers, laying high-capacity lines, modernizing substations to support these giant electric fleets, it literally takes years.
Yeah, I read that a school district might secure federal funding to purchase 200 electric buses, only to be told by the utility company that connecting the chargers will take 36 months.
3 years just to plug them in. If you're managing a logistics fleet today, that is the reality keeping you up at night.
You can't just tell parents, sorry, the school buses won't run until 2029.
Right. And that gridlock is forcing the market to develop some really pragmatic workarounds.
Like the off-grid stuff. Pioneer Power Solutions is rolling out this product line they call Energy at the Edge.
Yeah, they just secured a $7.1 million order from a major U.S. school district for 25 of their eBoost mobile units.
Which is specifically to charge those 200 electric buses without waiting for the grid.
Exactly. The core value proposition of a product like eBoost is immediate deployment. They bypass the utility delay entirely.
And Pioneer is seeing similar traction across the board, right?
Right.
I saw they logged another $1.8 million in orders from a California school district, a utility in the Southeast, and a major Canadian airport.
The demand is definitely there. And beyond the physical hardware, there are financial workarounds emerging too, because the upfront capital expenditure for these massive charging depots is a huge hurdle.
Right, the CapEx versus OpEx problem.
Exactly. So InCharge Energy is deploying a charging as a service or CARAS model.
Okay, how does that work?
Instead of a business buying the hardware and paying for the massive installation, InCharge handles all the capital costs. The business just pays a predictable monthly operating fee.
Oh, that's smart. It shifts the entire burden from CapEx to OpEx, which fundamentally lowers the barrier to entry for a logistics company.
Removing friction is really the defining theme of this current transition phase. Another prime example from our stack of sources is Beam Global's EV ARC.
Oh, the solar canopies. I love the elegant simplicity of these things.
Yeah, it's a fully off-grid, solar-powered charging canopy, and its design solves several physical constraints at once. It fits the exact footprint of a standard parking space.
Meaning a business can just drop it into an existing lot without losing any parking capacity.
Right, and without applying for complex zoning and construction permits. No trenching through the asphalt, no utility interconnect delays.
And zero utility bills.
Yeah.
The specs and the release note it deploys in minutes is flood-proof up to 9.5 feet and can withstand 160-mile-per-hour winds.
It's a very robust solution.
But I do have to push back on another product. Pioneer Power announced the eBoost D. The source explains this is an off-grid mobile charger that generates electricity using renewable diesel.
I know where you're going with this.
I mean, are we completely defeating the entire purpose of an electric fleet if we are literally using a diesel generator to charge the batteries?
It definitely seems contradictory at first glance, but it provides something invaluable to these fleets' operational certainty.
Okay, break that down for me.
Well, imagine the stakes for an airport logistics manager. Ground support equipment like baggage tugs and pushback tractors, they're all being electrified.
Right.
If the local grid goes down or that utility connection just isn't finished yet, you cannot ground hundreds of commercial flights.
Ah, I see. The cost of failure is too high.
Exactly.
Uh-huh.
Off-grid systems running on renewable diesel provide this necessary band-aid. They bridge the gap between our lagging grid reality and a fully electrified future.
Okay, that makes sense. It's a stepping stone. But, solving the grid bottleneck by moving power generation to the edge of the network creates a totally new, entirely unexpected problem.
Right, the automation problem.
Yeah, if we deploy these remote solar canopies for a fleet of completely autonomous vehicles like Waymo robotaxis or Tesla cybercabs with no steering wheels, we hit a somewhat comical physical roadblock.
Who actually plugs the cable in?
Exactly. Every charging standard we rely on today, whether it's Tesla's NACS or the standard CCS plug, is built on the assumption that a human with functioning eyes and hands is standing there.
Yeah, a human aligns the car, grabs the heavy cable, seats it firmly in the port, and authorizes the payment. Take the human out of the loop, and the system fails.
Which leads us right into the academic research on the Autonomous Charging Alignment Protocol, or ACAP.
This paper is fascinating. It's the underlying software architecture designed to make driverless charging actually work.
And it avoids just hand-waving it and saying, oh, a robot does it. It breaks the entire process down into a 14-state, finite-state machine.
Basically, a strict automated decision tree that manages every single micro step of the physical connection without requiring any human judgment.
Right. And the most complex challenge that state machine handles is the physical alignment. I mean, a robotic arm needs millimeter-level precision to insert a high-voltage plug safely.
But a car pulling into a parking lot is dealing with macro-level navigation. So ACAP solves this with this brilliant three-stage positioning cascade.
Yeah, the authors of the paper use the analogy of a spacecraft docking sequence at the International Space Station, which perfectly illustrates this sort of narrowing funnel of precision.
That's a great analogy.
So stage A is the course approach. It relies on a CV2X beacon. That stands for Cellular Vehicle to Everything. Basically, the charging station acts like a localized 5G lighthouse.
Right, and the car's GPS uses that beacon to navigate into the general vicinity of the charging bay, getting it within, say, 1 to 3 meters.
Okay, so that's the long-range radar. What happens when it's in the bay?
Once it's in the bay, the protocol hands off to stage B, which is precision guidance. This step utilizes ultra-wideband, or UWB, radio signals.
Okay, so if CV2X is the radar, UWB is like the spacecraft's precise maneuvering thrusters.
Exactly. The charging station and the car ping each other hundreds of times a second, guiding the vehicle until it stops within 5 to 10 centimeters of the target position.
Oh, wow, that is close. And then finally, stage C is fine docking, the physical latching of the airlock, basically.
Right, and the station uses structured light for this.
Which is really cool. Instead of just a regular camera, it projects a precise grid of lasers onto the side of the car to map the exact 3D topography of the charge port.
It's very similar to how Face ID works on a smartphone, but obviously scaled up for an automobile.
Yeah. And that 3D map guides the robotic arm to insert the plug. The paper actually notes this entire software handshake, from entering the bay to locking the plug, takes less than 45 seconds.
Which is fast. Speed is critical for fleet efficiency, but the protocol's primary focus is actually on safety and variance.
Because of the electricity involved.
Yeah, we are discussing the automated transfer of up to 1,000 volts of direct current. Without a human to visually verify the connection, the risk of a catastrophic arc flash or electrocution is immense.
Right, you don't want a robot blindly jamming a live wire into a piece of metal.
Exactly. So ACP mandates strict hardware-level guarantees. The robotic arm is physically locked and cannot actuate unless the high-voltage circuit is entirely de-energized.
So the power simply cannot flow until the mechanical lock is confirmed. That removes the risk of a mere software glitch causing a live wire disconnect.
Right, but physical safety is just one hurdle. Taking the human out of the loop opens up a massive cybersecurity vulnerability.
Oh yeah, the hacker in the van.
Exactly. If the car is driving itself and a robot is handling the power, how does the car actually verify the station is legitimate?
The paper details threat models for this, like the broken wire or deception attacks. It suggests an attacker with a cheap 1-watt software-defined radio could sit 47 meters away and completely hijack a charging session.
Which sounds insane.
I was so skeptical of this at first. It sounds like a plot from a sci-fi movie. Why would someone sit in the bush with a radio just to hack a charger?
Right, what's the incentive?
But thinking about the logistics managers we discussed earlier, the stakes suddenly make a lot of sense. If an attacker can broadcast a signal that aborts every charging session in a 50-meter radius, they can paralyze an entire city's autonomous supply chain.
It becomes a localized denial-of-service attack on critical physical infrastructure.
Which is terrifying.
It is, but the disruption of infrastructure is just one threat. The financial incentive is arguably even greater.
How so?
Well, the ACAP protocol includes a completely automated financial settlement layer. When the vehicle successfully connects, it exchanges a fleet authorization token to automatically deduct funds for the power consumed.
Oh, I see.
So if a malicious actor can spoof a station's identity, they can trick the fleet into paying for phantom charging sessions. They'd be committing massive billing fraud entirely over the air.
Okay, so how do they stop that? because the protocol's defense against this is something called cryptographic spatial anchors, or CSA, right?
Yes. And the underlying logic is fascinating because it relies on physics rather than just software passwords.
Oh, I love that.
The goal is to cryptographically bind a vehicle's digital identity to its verified physical location.
Okay, so the hardware foundation for this involves automotive-grade TPM 2.0 chips in both the vehicle and the charger, which secures their digital identities.
Right. And when the car enters the bay, it uses that ultra-wideband radio we mentioned in Stage B to measure the exact distance between itself and the charger.
So if the system using radio waves, and radio waves travel at the speed of light, it's basically calculating distance based on the exact time it takes the signal to bounce back and forth.
Exactly. So think about the hacker. If a hacker is sitting in a van 47 meters away, trying to relay a fake signal to trick the car into authenticating, that extra physical distance means the signal has to travel further through the air.
Because it has to bounce to the van and back.
Yes. And the precision of ultra-wideband is what makes this defense work. The system is measuring time in nanoseconds.
Wow.
So if a hacker intercepts and relays the signal, the extra distance forces a microscopic delay.
Because the speed of light is a universal constant, that delay is literally unavoidable. You can't hack physics.
Exactly. You can't fake the speed of light.
The paper notes the threshold is 1.5 nanoseconds. That is 1.5 billionths of a second.
It's incredibly tight.
Yeah, and if the hardware detects that microscopic delay, it calculates a distance discrepancy of about 45 centimeters.
Which is enough to fail the test.
Right, the protocol instantly recognizes that the digital identity being broadcast does not match the physical location of the radio source. It flags it as a relay attack and just aborts the high voltage connection entirely.
So physical distance becomes the ultimate cryptographic firewall.
It's so elegant. ACIP provides this underlying secure software architecture, but, observing how the physical hardware is evolving alongside it is equally compelling.
Definitely. Because AC Happy is brilliant for robotic arms, but what happens when the industry decides to just skip the robotic arm entirely?
Yeah, we touched on Beam Global's off-grid solar canopy earlier. According to the commercial sources, Beam Global just entered a major partnership with a company called HEVO.
And HEVO specializes in wireless EV charging.
Right. They're merging Beam's off-grid solar footprint with HEVO's wireless charging pads.
Which fundamentally shifts the infrastructure requirements. HEVO utilizes magnetic resonance induction.
Basically, a transmitter coil in the ground pad and a receiver coil mounted underneath the vehicle.
Exactly. When alternating current flows through the ground coil, it creates an oscillating magnetic field. If the vehicle's coil is tuned to the exact same resonant frequency, the energy just transfers across the physical air gap.
It charges the battery without any cables at all.
Right. No cables, no moving robotic parts, no trenching for grid connections.
An autonomous vehicle just uses that AC cap alignment protocol to park perfectly over the pad, and the power flows.
And the policy context driving this is really substantial. The sources highlight that the U.S. administration is actively signaling support for streamlining autonomous vehicle deployment.
Right, and internationally, Abu Dhabi has explicitly stated its goal to lead the world in rolling out AV fleets. So there's a booming global market actively clearing the runway for this exact intersection of technologies.
But of course, engineering must always account for failure states. Batteries degrade, software glitches occur.
Autonomous vehicles will inevitably miss their charging windows and end up stranded on the side of the road.
Yeah, a resilient ecosystem requires a failsafe.
And the ultimate failsafe detailed in our stack comes from a partnership between Be Charged EV and Urgently. They're building a human-powered nationwide emergency network specifically targeting major metropolitan areas.
Kind of like roadside assistance for the future.
Exactly. If an EV is stranded, they dispatch a mobile response vehicle equipped to deliver Level 3 ultra-fast charging directly to the car.
And Level 3 charging is a crucial distinction here.
Right? Unlike a standard wall outlet that provides alternating current, Level 3 delivers high-voltage direct current. It bypasses the car's internal converter and pushes energy straight into the battery pack.
It provides enough range in just a few minutes to get the vehicle to a permanent station.
It is, for all intents and purposes, the AAA of the electric age.
Synthesizing all these diverse elements really reveals a profound transition.
It does.
We are witnessing the real-time evolution from a centralized grid architecture, one that's heavily reliant on human operators and fossil fuel combustion, to a highly decentralized, autonomous, edge computing energy network.
It is a complete paradigm shift.
Right.
And honestly, understanding that shift is exactly why we do these deep dives.
You really have to look at the whole picture.
Yeah. If you are analyzing investment trends, managing a logistics supply chain, or just striving to be the most well-informed person in the room, you cannot rely on the sanitized marketing narratives.
You have to look past the greenwashing of legacy fuels, like we saw with the propane marketing.
Right, and actually grasp the mechanics of the infrastructure being built. It's the off-grid solar canopies, the magnetic resonance pads, the cryptographic spatial anchors, and these mobile fail-safes that are actually making this autonomous future possible.
It's the nuts and bolts of tomorrow.
Exactly. But before we wrap up, I want to leave you with one final kind of mind-bending implication of this technology to explore on your own.
Oh, this is a good one.
We just detailed how the ACAP protocol can authenticate a vehicle's exact physical location down to the millimeter, right? And securely transact a fleet authorization token to pay for energy without any human input.
Right. Totally automated.
If this vehicle-to-infrastructure technology becomes the ubiquitous standard for how cars interact with the physical world, it opens a fascinating door.
A slightly concerning door, depending on how you look at it.
Yeah, a system that perfectly tracks location and securely debits an account could easily be adopted by municipalities. Could this exact same protocol eventually be utilized by governments to automatically track and tax every single mile a driverless car travels?
It's certainly technically possible.
We are busy building the perfect, frictionless infrastructure for automated charging, but we might inadvertently be fundamentally altering the concept of freedom of mobility and privacy in the process.
It's a huge trade-off.
It really is. It is definitely something to keep in mind the next time you see a pristine, glowing advertisement for our driverless future. Thank you so much for joining us on this deep dive. We'll catch you next time as we keep looking behind the facade.